Hi, I'm David. Today we're going to look at this function, f of x equals 3 cosine x. And suppose we want to find the inverse of this function. Well, we run into some problems, and let me show you why. Let me first draw a sketch of 3 cosine x. I'll draw an axis right here. Now this is going to look like the cosine function, but there's a 3 multiplied out front. So what that does is that increases the amplitude by a multiple of 3. So instead of oscillating between 1 and -1, it oscillates between 3 and -3. So let me go ahead and put those on our graph. 3 and -3. And I'll put our regular increments for trigonometric functions. I'll put pi and 2 pi. And I'll go all the way out to 3 pi this direction. And I'll go out to -pi this direction. Okay, if you remember, cosine of 0 is 0, or cosine of 0 is 1, pardon me. So 3 cosine of 0 is 3, so it starts up here. And it does something like this. And it keeps on oscillating like that between 3 and -3, all the way to infinity to the right and all the way to -infinity to the left. Okay, so if we're trying to find the inverse of this function, we run into a problem because this function doesn't have an inverse, because this function is not 1 to 1. All right, but we're not stuck. We can take just an interval of this function and figure out, can we find an interval where the function is 1 to 1, where it passes the horizontal line test? We notice right now that if I drew a horizontal line anywhere between y equals -3 and 3, it would hit this graph infinitely many times. All right, so I can't use the whole function. The function is not 1 to 1. However, can I find an interval of this function where it is 1 to 1? Now, I'm going to pick this interval in kind of a little bit of an intelligent way, and I'll show you why here in a minute. But I'm going to pick the interval between 0 and pi. The interval between 0 and pi. So I'm going to let x fall between 0 and pi. And hopefully you can see that if I'm anywhere on this graph between 0 and pi, that little section of 3 cosine x is 1 to 1. It does pass the horizontal line test. So I'm just going to look at 3 cosine x between 0 and pi. There are lots of other sections of this graph that I could have chosen that are 1 to 1, but I'm going to specifically choose this one between 0 and pi. Okay, now that I'm only working with this chunk of the graph, I'll redraw it. Now that I'm only working with this chunk of the graph, this thing is 1 to 1. This part of the graph is 1 to 1. So now let's try to find its inverse function. Okay, in order to do that, I can write y equals 3 cosine x, and then I can switch the x and y and solve for y. So what I mean by that is x equals 3 cosine y. If I can solve this equation for y, then I've got the inverse function. So I do a little bit of algebra, divide both sides by 3. And now I have a cosine y sitting right here. When I've got a cosine y, the only way to undo this function and get y all by itself is to do the inverse of cosine y. The inverse of cosine y is arc cosine. So I've got to use that inverse function. So let me go ahead and do that. I'll take arc cosine of x over 3 equals arc cosine of y. Now, when I have arc cosine of y, that's two functions that are inverses of each other, cosine and arc cosine, and they're undoing each other. So this right side of the equation is just going to be y. So finally what I've got is I've got y equals arc cosine of x over 3. And that's going to be my inverse function. If f of x equals 3 cosine of x, f inverse of x equals arc cosine of x over 3. Now the last thing I might want to look at is what's the domain of this function? For what values of x is this well defined? And this goes into where I chose my values of x between 0 and pi here. The domain of f inverse of x is the range of my original function. So let's look at the range of my original function, the range of f. F went between 3 and negative 3. So the range of f is y is between negative 3 and 3. So therefore, the domain of its inverse, f inverse, is x, is between negative 3 and 3. If I were to draw a picture of this, I would take this entire graph right here and I'd kind of turn it on its side. I replace the x's with y's and the y's with x's. So since the range of f is negative 3 to 3, the domain of f inverse is negative 3 to 3. Thanks for watching.